Since its arrival in December 2003, Europe's first mission to Mars has been studying the composition of the atmosphere, mapping the surface, and, a space premiere, delving into the subsurface of Earth's neighbour. With one special quest for Mars Express, to find further evidence that water once flowed on the planet and could well still be present. For more than 2.5 years, the spacecraft's 7 instruments have delighted the scientists and the public alike with breathtaking views of the planet, its mesas, volcanoes, calderas, and numerous dry riverbeds. The high-resolution stereo camera, HRSC, has delivered grandiose vistas on the Martian landscape, like the Martian Grand Canyon, Valles Marineris, but several thousand kilometers long and twice as deep as the one on Earth.
We see mountain ranges, valleys, mesas, and this normally is caused by the action of water. And we see it in great detail in the images, in color, and we can sort of do instant science in this imagery almost.
HRSC has also provided bird's-eye views of the awe-inspiring Olympus Mons, peaking at 26 kilometers, the highest volcano in the solar system. Thousands of images from the HRSC camera have given insights into recent periods of volcanism and past glacial and geological activity, with incredible details, such as the fields of dunes created by winds, or the dust falling from a crater rim. Scientists have been able to redate volcanic and fluvial events on Mars, showing that regions of the surface have changed in a relatively recent past. The camera has also discovered snow and ice accumulation at tropical to mid-latitudes, and a huge frozen sea just below the surface in the planet's near equatorial Elysium region. A young sea, only 5 million years old, where the water apparently has come up from below in one sudden rush.
The implications are that there are wet, warm spaces beneath the surface of Mars. Now, we know that this sort of thing has happened throughout Mars's history, and the fact that it's still going on today is interesting because these are places in which life, I should say, might possibly develop.
Orbit by orbit, with views hundreds of kilometers wide and strips thousands of kilometers long, HRSC has today imaged more than half the Martian surface. From altitudes as low as 260 kilometers, it has pictured slopes, depths of craters and canyons, volumes of lava flows, thicknesses of geological strata, and the layers of polar ice. Taking stereo views of the terrain at a resolution of 10 meters and even 2.3 meters per pixel, HRSC has allowed an astoundingly accurate reconstruction of the topography. Invaluable in the selection of landing sites for future robotic and manned missions, and a basis for next-generation missions to map the planet on an even greater scale. Another Mars Express instrument has sounded, for the first time in planetary exploration, the depths of the red planet. In November 2005, the Marsis principal investigators exulted with the discovery of subterranean water. In one of its first observations, the Marsis radar altimeter revealed the presence of thick deposits of practically pure water ice hidden at a depth of several kilometers. It also located a basin 250 kilometers in diameter, buried 2.5 kilometers deep. Embedded in this structure, probably an impact crater, a thick layer of ice-rich material was detected. This discovery and other data have led scientists to the conclusion that the surface crusts in the Martian northern plains are not as young as had been suggested. This has led to question long-standing theories that Mars was once covered by vast oceans and for long periods. However, with evidence from HRSC and from the Omega visible and infrared spectrometer, the planet could have been covered by smaller expanses of water, but for much shorter periods. HRSC, Marsis and Omega have also observed the Martian polar caps, confirming that the ice there is water and that any frozen carbon dioxide is just a very superficial layer.
mixed with the CO2, there is a huge amount of H2O that we both see mixed with the CO2, and also apart from that, in a region where the temperature has sublimated the CO2, as for H2O to remain the major constituent of the South Polar Cap.
Whilst one marvels at the views of the Martian poles, such as the giant Chasma Boreale trough that almost divides the northern polar ice cap in two, showing in perspective layers of water ice and dust, the scientific community today agrees that the European mission has surpassed expectations. Its investigators have months of work ahead, and the data is still streaming down from HRSC, MARSIS, Omega, but also the probe's PFS, SPICAM and Aspera instruments. Analyzing data not solely about water, past and present, but characterizing the entire Martian environment, the atmospheric composition and eventual biological processes, its high-altitude clouds, and the scavenging effects of the solar wind.
Mars in its evolution was, at least in the beginning, similar to Earth. So there was an environment where life could have evolved, and we have to find out. And this is all what, so to say, Mars Express is right now about, and all what the coming Mars missions are about, to look for extinct or extend life.
More anecdotally, Mars Express has also helped dispel a long-standing public myth, ever since this picture from the NASA Viking orbiter in 1976. With the spectacular HRSC views of the Cydonia region, there can no longer be any doubts. The face on Mars is certainly not of alien origin, just a geological formation, but certainly no less spectacular.